Here we go. So I'm going to tell you a little bit more about our program and the data questions, which everybody is rightfully fascinated with, because these are, I think, super important questions that lead to grants, they lead to public accountability, and the answers to all these questions that are in our minds. How are these lakes interconnected? Does it matter if I do anything at this particular lake? How does my lake affect another lake? We all are wondering about those questions, so data is the only way to get a handle on that. So I collect it really quickly. It helps you with planning, it helps you with accountability, and it helps you make a case that your program actually made a difference. Because anecdotal information about why your program's important is important. You have stewards saying, they feel good about it. You have people, visitors from the public, happy that there's a boat launch steward there. But anecdotal information dissipates and lasts for just minutes or hours or weeks. But data is almost a permanent record of the impact of your program. You can also perform calculations such as, you can do these calculations, dollars per inspection, dollars per save, dollars per week, for those people who like those kind of analytics. So that's helpful. So what does it show us? If you look at individual lakes, obviously the big question is what's happening on my lake? And this is where Steward programs started, on the lakes that you individually care for. So let's talk about the data for individual lakes. So the Cranberry Lake Association asks, well, what's happening at Cranberry Lake? So this year's data looks like this: about 1,200 boats inspected. Different types of watercraft. So the question inevitably is, what kinds of watercraft are we talking about? Human-powered or motorized? That would shape your strategy. If we're only canoes and kayaks, well, then that may change your coverage strategy. Well, for Cranberry Lake, it's pretty clear that most of the boats are motorized. Okay, so this gives you an idea. But you know what? You get a couple of rowboats, and sometimes you get docks. In this case, we didn't this year. Then the question I think that everybody's really interested in is, what did we find? How many boats are dirty? And what are the details? So for instance, at Cranberry Lake, about 3,000 people, about 6.7% of the watercraft had something on them, native or invasive, and only 1% in Cranberry Lake had AIS that were confirmed. And like the question before, what do you do with these samples? Do you send them to the main office? At our scale, we can do that. Stewards are instructed to bag and label questionable AIS. If they think it's AIS, send it in and we confirm it. So these AIS are actually confirmed at the central office. The non-ones, if they think it's a native, that doesn't get confirmed. So they could be doing false negatives. So that could be a problem with the data too. So we see, now we can breathe a sigh of relief maybe that Cranberry Lake, only 1% of the watercraft have invasive species, coming, either on the boat, entering or leaving. This also tells you, are the boats dirty or coming, or are leaving the boat launch? In this case, which makes sense because Cranberry Lake is variable leaf milfoil, you need to focus on the boats leaving. Then the question that everyone really is interested in, those boats where you did find the invasive species, where were they previously? Okay, where's the smoking gun? For Cranberry Lake, it looks like Lake Erie and Lake Ontario and the St. Lawrence River, just what you would expect. Destinations to the west are the smoking gun, right? But you could find, something that might surprise you. Perhaps we'd find that Saranac Lake is the smoking gun. We don't know. But this is the question that you can drill down and find what boats actually were carrying the invasive species. You could even find out what horsepower those watercraft were, or were they motorized or not motorized. That information is all there.
When you say dirty, what does that mean?
Well, for our purposes, if a boat fails the clean, drain, dry standard. So there's something on it, there's bilge water, there's mud, there are spider webs, not human, like beer cans.
Doesn't necessarily mean an invasive species.
It doesn't mean invasive species. So we're counting leaves, pine needles, all those things, all the things that we find that may or may not be invasive species. So about 10% overall of our boats for the entire program, 60,000 boats, have something on them. About 3% have invasive species on average. But at Cranberry Lake, the boats are cleaner than average. So you can see, we also ask what spread prevention measures you take. prior to coming here, did you take a spread prevention measure? And you can track this over the years to see if your users are having a standard level of compliance and awareness of watercraft inspections, watercraft decontamination behaviors or not. You can track the number of AIS removed. This past year was about an average year. 2012, we had 27 AIS that we found at Cranberry Lake. So it's actually getting a little bit more, you could argue that there's fewer being found. What does that mean? Either our stewards aren't doing the same level of work, or perhaps the weather conditions that year meant that there are less fragments floating around. Then we also asked, where do the watercraft come from? With data, if you track this for thousands and thousands of surveys, you get a picture. And the picture is this. These are just the top 50 at Cranberry Lake. The common answer is, where were you the last 2 weeks, or where was this watercraft last used? The same lake is the most common answer, or nowhere. So that's pretty much the pattern we're finding across all 50 of our boat launches. So we're learning about how people use their watercrafts. So that was just one lake. If you scale this up to 50 boat launches, then we find that there's about 44,000 watercraft that we inspected, and overall we removed 1,100 invasive fragments. So if you scale these programs up, of course the numbers get more and more inclusive. So I want to show you how this translates visually. When you have good data and you have someone on your staff who can do GIS maps, you can start representing the spread vectors, is what we call them. Where are the boats coming from before they get to each of these lakes? So it's a signal, essentially. How often does someone say, well, I was in Lake Ontario, the last time this watercraft was used was Lake Ontario. Well, Lake Ontario and the St. Lawrence River and then Oneida Lake are the top three. Okay, so now we know that those three source bodies are the most significant threats for this particular water body in terms of Cranberry Lake. But it's still a comparatively small number, only 12 to 42. So it's still a fairly insignificant number in terms of the 1,300 boats that we inspected there. It's still a small number, but it's the strongest signal we've got. So if you start layering these maps together, we have about 50 of these maps from our 50 different locations. You can start seeing patterns. And obviously the lakes that are on the western side of the Adirondacks, you would assume have a bias toward the western part of New York State, and that's true just because of logistics and human nature. People are coming from the western part of New York State to go to Cranberry Lake and to go to Fourth Lake. So this is confirming what you might have guessed, but it's good to confirm your suspicions. It also shows that there are particular connections that you wouldn't have known otherwise. For instance, Fourth Lake, there's this connection with Oneida Lake. Obviously it's fairly close, it's a large lake, but now we know that Oneida Lake, Canandaigua, Cayuga, Skaneateles Lakes, these lakes, if they had steward programs cleaning the boats leaving their lakes, that's going to provide extra support for the entire system. So this is what we're trying to show you with data, analyzing data over a large landscape, that each of these water bodies is not in isolation. We're so happy that there are steward programs in the Finger Lakes. And if we did this the other way around, you probably would see a few boats coming from the Adirondacks going to the Finger Lakes, and therefore those lakes should be receiving a benefit from our steward programs too. Okay, so that's just two lakes. When you start mapping them together, you start seeing theoretical associations of where most of the lakes are exporting users to within our system. So you can make a map like this, and that map then will show you that all of these steward locations then have preceding visitors coming from other lakes within the system and also outside of the system. This is where we were last year. So we had pretty good coverage across the Adirondack Park. It's an unprecedented level of coverage. This is probably the level of coverage that we want to see everywhere in New York State. But we have, we're a few years ahead of the rest of the state for lots of good reasons and maybe some just luck. But the Ps are our partner organizations, state parks, the Lake George Basin Program, or the Lake George Association, and Park Commission, and then smaller municipal programs like at Schroon Lake, Canada Lake, etc. So we're pooling all this data together, and then we analyze it at Paul Smith's College to make a much more comprehensive picture. All right, so this is where I think it gets the most powerful. This map shows us spread vectors. A spread vector is a Steward observed watercraft launch from a confirmed last use location. So the boat itself is the vector. So it just means an opportunity for transit of any organism. So from a preceding lake to this lake. And these are not guesses. The Steward at, let's say, Fourth Lake asked, where were you last in the last, where was your boat used last? And we got an actual response from Stillwater, for instance. So these are not just guesses. These aren't, where do you think you're going to go next? These are actual confirmed vectors. So if you just look at the primary outbound vector from each of these lakes, or the most common one within our database, then we see that Stillwater and Fourth Lake, Stillwater is mostly connected with Fort Lake. Fourth Lake, it's connected in ones and twos with many other lakes, but the largest signal was from between Stillwater and Fourth Lake, from Indian Lake to Lake George, from Sacandaga Lake to Great Sacandaga Lake, from Great Sacandaga to Lake George, etc. So if you just looked at the most common observed connection, these are the most common observed connections. So you can start seeing that there is a network, right? There's these associated lakes up and down the Northway, the northern Adirondacks, and then the Fulton chain, which connects with the northern Adirondacks through Long Lake and Tupper Lake. So those are the primary vectors. If you add the secondary and tertiary vectors, then the picture gets a little bit more complex, and you have to take some more time looking at it. But the connections increase, essentially. So the idea is, how can you cut off these associations between the lakes? How can you intervene and stop these vectors? And that's where a regional strategy comes in. That's where regionally placed decon stations and stewards at various locations, that's where that comes in, to disrupt the entire flow of invasive species across the landscape. So it's pretty exciting. So if you look at the number of, this map is key to the number of visits. So if you go back to this map, okay, sure, there's some red arrows here that show a primary outbound from Blue Mountain Lake to Racket Lake. Well, there's very few visits there. So if you have limited amount of money, where are you going to put your money? You want to put your money where there's the highest amount of traffic. Well, so this is what we did, is we did another map based on the total number of visits. And of course, Lake George shows up because it gets so much traffic, and there's stewards there 7 days a week at 7 or 8 different locations. So it tends to dominate numerically. But you would start looking at the most busy corridors are between Great Sacandaga and Lake George, Saratoga and Lake George, Champlain and Lake George, and then you'd start looking at the yellows. Lake Placid and Second Pond, that's a very busy corridor. Tupper Lake to Second Pond, another busy corridor. So you would start looking at amount of use, okay? So this is how the vector analysis helps. You can also overlay this on the road network. So instead of looking at these arrows that are artificially hopping over the landscape, you can superimpose them on the highways and see what stretches of highways, according to our actual data, should the boats be traveling on most frequently. So we know we've got a connection between Sacandaga and Great Sacandaga Lake, one between Sacandaga and Lake George. Well, they're most likely to be traveling on Route 30 here, and what is this? Is this Route 8? So that's where you would put, decon stations. So this helps you understand how people are traveling over the landscape on the roads, okay? So I included in this map inbound vectors from outside the Adirondacks because the map gets a little hard to interpret if you put it all there at once. So I just added this layer in so you can see that the Adirondacks is not isolated. It's connected to other destinations. For instance, Lake Ontario is most frequently coming to Lake George in our data set. St. Lawrence River is most frequently coming to Lake George. Lake Erie to Lake George. Okay, but Oneida Lake's primary input is to the Fourth Lake, Canandaigua Lake, etc. So this shows that the Adirondack region is not isolated and does have predictable inputs from outside the park. So I added secondary and tertiary here, so it gets a little more complex. You can see that St. Lawrence is also dumping into, the St. Lawrence River is dumping into Cranberry Lake. Lake Ontario is also dumping into Cranberry Lake. Lake Champlain A secondary also goes directly into second pond. So this makes it a little more rich in terms of the patterns. So all these arrows might drive you crazy. It helps us when you spend a lot of time with them. On for you just looking at this for 5 minutes, it might be confusing. But it's useful for us when we think about where we're going to put all these decon stations and stewards across the entire prism. So this is prism-wide data collection and data stewardship and data sharing. So I would, this is, I think, a goal that we need to shoot for. What do we collect? This is the big question. Where have you been last? Where has this watercraft been last within the last 2 weeks? Most frequently occurring response is it's been nowhere. Second most frequently, the same lake where the steward is. So second priority is what do we find on each inspection? Is the boat launching and retrieving? What spread prevention measures they took before? The inspector name, so you can go back and track the data a little bit more easily. So we do use Snap Survey software, which is at snap.com. It's just a company that we discovered in New Hampshire that has this is more for marketing data. So those people who are in malls who are asking your consumer preferences, they use this kind of data, but we use this for our purposes as well. It generates drop-down menus. There are all these radio buttons that you can select to show what you found on each inspection, and then it saves it. And then, whenever you get in a Wi-Fi enabled location, all of your surveys get uploaded to the cloud automatically. So there's not a lot of room for user error. It eliminated user error essentially entirely. So we did paper forms, and you can come visit us, and I'll show you our dungeon of paper forms that we have for the early years. And they're neat to look at, but this saved us so much time and money. We were paying someone to do all this work, so this is way cheaper than paying somebody to do work and have all the human error of the person doing the work. Okay, so this is what it outputs. We still have to clean the database a little bit, but there's around 30 fields, 30 rows, and around 45,000 lines. So that's millions of cells of data, and so it's a lot. But now you can use pivot tables and really see how these different variables interact. So this is one field. I'm just going to show you a couple different screens. Did they inspect the boat, wash the boat? Where was the last water body used? And it goes on and on and on. So you get this, massive resource of data that is super useful. You can share it with others. And actually, we put a lot of this online for public use. So we publish this in our annual summary in tabular form. You can download this at our website. This shows you every lake. I don't know. There's 50 or 60 places where we were last summer. And then we do an individual report for the lake associations. They just care about Tupper Lake, for instance. They just want to look for their lake. So here's the breakdown just for Tupper Lake. So they can see both the individual lake results, but then they can see the bigger picture. And essentially, we're most interested in how the bigger picture, how all the pieces are fitting together. Okay, so if you're going to collect data, we suggest, and we would love to get your data, we suggest that you at least ask where were you last for a watercraft. If we had that and nothing else, that would help us understand the pattern, the network of how the lakes are connected to each other. And of course, if you can get the results of the inspection, that's great too. But even if you just ask, where were you last? That would be super helpful for us. And then this is who we're funded by, a lot of people. So these are a lot of folks who want specific things. They only care about Great Sacandaga Lake. They care about Rainbow Lake. So we have to satisfy a lot of these stakeholders, but we get their data. So that's data. I wanted to show you our website. So go to ADK Watershed, and watershed.org. And we have a lot of this data in a searchable database available to the public. But if you go to inspection searchable database, we developed a searchable database that will output bar graphs, trends over time. You can compare lakes, compare two water bodies, boat origin states, organism by boat type. We decided to make this data available to the public because you paid for it. So play with this, tell me if you like it, if it's useful for you, and give me some feedback.